Here we have two bars or two linkages, one here and one here, and there's a pulley attached here and a pulley attached here, and then a cable coming down, and then it attaches here. And there's a load on the cable. So again, I just drew free body diagrams of everything here, and we can sum forces and moments on the whole structure, the structure as a whole, or any one of the individual components here. I used the results from the previous problem to just replace the pulleys with just points here. But we have to be a little careful if we sum forces moments on the entire body, because the load from the pulley actually acts off the edge here because of the pulley's radius. So here are all the vectors to each point in the problem, and then I also define a prime, which is 0.25 meters to the right, but to the left of point A, and that's where the reaction force from the tension in the cable acts on the entire body. So when we sum forces on the entire body, we get the tension in the cable, and then FD and FE. FA cancels out. T here cancels out, and all these other internal forces cancel out. This does not cancel out, but it actually acts over off the body a little bit here. So that's why we have to be careful about when we write our moment equation, that this force here actually acts at A prime. So our torque equation becomes this, and our torques from our moment equation, and then our torques from D and E, the reaction forces. And then I looked at the lower body here, because it's got less going on, so I figured that would be an easier one to formulate. So we get minus T, and so that's in the vertical direction, and we have A and then E acting. So we have, and then the moment torques. Okay, so there's no torque from A because that's where we used our origin, some torques about. And so again, we get 6 equations and 6 unknowns. And we can find FA, but they didn't ask us for that. So they asked us for FD and FE, and FD is 13.6 kilonewtons in the x direction and 7.5 kilonewtons in the y direction, and FE is minus 13.6 kilonewtons in the x direction and minus 2.7 kilonewtons in the y direction.